Hello guys, welcome to Codenzyme, and in this video let's discuss this problem LCM Mania. And the problem statement goes like, I think this is a spelling mistake, it should be chef. Chef gives you an integer n and you need to find three positive integers a, b and c such that n is equals to LCM of a and b plus LCM of b and c plus LCM of c and a, where LCM denotes the least common multiple. And if there is no solution, print -1. If there are multiple solutions, we can print any of them. And so if you are not familiar with what LCM is, I think you should first read about that and come here. I will not be explaining what LCM is. And the input format goes like, we have a single integer t denoting the number of test cases, and then the first line and the only line of each test case contains an integer n. And we need to output three integers a, b and c which satisfy the given condition, and if there is a no solution, we have to print -1. And if there are multiple solutions, we can print any of them, and t goes to 10 to the power 5, n goes to 10 to the power 9, right? Okay, so let's see the approach now. So we are given an integer n, and we need to find three integers a, b and c such that n is equals to LCM of a comma b plus LCM of b comma c plus LCM of a and c, right? Yeah. I mean, if you try to carry out some cases by hand, you will realize that there is no possible solution if n is a power of 2, right? Then we have no solution. Okay, also since a, b and c are greater than equal to 1, then obviously my n should be greater than equal to 3, otherwise we have no solution, right? Now we can divide this into two cases, like when n is odd and when n is even. So let's first see the case when n is odd, because that is an easier version of the easy to solve. So when n is odd, then by Euclid division lemma we can say that n is 2y plus 1, right? Some multiple of 2 plus 1, that will and that is the format of n, right? Because it is an odd number. Now if n is odd, 2y plus 1, then it is kind of easy, or I mean, I think if you try it out, you can see that the solution for this will be 1 comma 1 comma y. This will be the ABC numbers. How you can just try it: LCM of 1 comma 1 plus LCM of 1 comma y plus LCM of y comma 1, which is equals to 1 plus y, which is equals to 2y plus 1, which is equals to n. So if you are given an integer n and it is an odd number, you can directly say, okay, y is equals to n minus 1 by 2 here. Then you can directly say my answer will be 1 comma 1 comma n minus 1 by 2 if n is odd, right? Then we have another case when n is even and not a power of 2. If it is a power of 2, then we don't have a solution. Okay, and we will see why. So basically, if n is not a power of 2, but it is but it is even, then obviously we will have some n as some power of 2 times an odd number, right? And that is 2y plus 1, right? And for this we have seen the solution is 1 comma 1 comma y. So what will be the solution for this whole thing? For this whole thing, it will be 2 raised to power k comma 2 raised to power k comma 2 raised to power k times y, right? You can try taking the LCM of 2 raised to power k comma 2 raised to power k plus LCM of y into 2 raised to power k comma 2 raised to power k plus LCM of I tried these two and 2 raised to power k comma y into 2 raised to power k. So this will give me 2 raised to power k plus y into 2 raised to power k plus y into 2 raised to power k, which is equals to 2y plus 1 into 2 raised to power k, which is again n, right? So if it is so our solution goes like, if you have an n, first check if it is less than 3. If it is less than 3, print -1. If it is exactly a power of 2, we have to print -1. Then if it is an odd number, my solution is 1 comma 1 comma n minus 1 by 2. And if it is an even number but not a power of 2, first we need to calculate our k value, this 2 raised power k value. After that we have to figure out our y, 2y plus 1, or I can write this odd part, and then I can say my solution will be 2 raised to power k comma 2 raised to power k into y into 2 raised to power k, right? So that is our solution. As for the time complexity, this is like an O of 1, right? This is also an O of 1 type solution, and for this one it will take like log 2 n time, right? So log 2 n time solution, right? So in worst case our solution is log 2n. Okay, let's see the code now. So we have a solve function here for every line n. First, if our n is less than 3, then we have to print -1. Otherwise we have to check if it is a power of 2. So we can keep on dividing n by 2, and I'm checking here what is the power of 2 in the n. And now if after dividing it continuously by 2, if my n is 1, then obviously n is a power of 2, and we have to say okay, there is no possible solution. We can print -1 here. Otherwise we can figure out what our m is, or I can say y here. I mean, in the explanation I wrote y, so that is this. And now I can simply print -1. I can simply print 2 raised power k comma 2 raised power k, because I changed my k to 2 raised power k in this step, right? So 2 raised power k into 2 raised power k into m into k. What if my n was an odd number? I didn't try that, because if it is an odd number, my k will, this while loop will not work, and my k will be equal to 0 and n will not be equal to 1. So it is handled here. Okay, so I hope I was able to explain it properly, and thanks for watching. I'll see you guys next time.